Hello everyone. In the last lecture, we saw and we completed a Python library, which is Rasterio, in order to handle our raster data set. And we also saw how we can open any imagery and then how we can see the various attributes or the metadata information related to that particular imagery. And then we moved forward with some of the functions that we can follow using those library or the functions that were present in the Rasterio Python library, and that included if we wanted to stack various bands together, or how we can display a single band using some of the functions, and how then we can stack in order to visualize our data set using some band combinations. And then we saw, which was a bit difficult and tricky, that was how we can convert or transform our data set using the coordinate reference system. So this is what we saw in the previous lectures about the Rasterio Python library. But now today we will be reading about uh, or knowing the functionalities of another Python library, which is Xarray. And today, and maybe in the next lecture, we will be uh, covering this entire Python library, which is Xarray. So, it is a very powerful tool in Python for working with multi-dimensional geospatial data set. And if you work with NetCDF file or satellite imageries or Earth Engine exports or maybe model outputs, then you are going to love this particular library of Xarray, because many of you must be working with the climate data set, which is again important in order to correlate your work with any of the uh, the parameters, as you can say that if you are working with any of the groundwater data set, or you are working with glaciers, or um, like climate data set is again very important in itself, as well as when you are working with any other you can say parameter that is your focus, and you want to correlate it with the climate data set, then you would come across the NetCDF files in which it is available. So if you are working with any of such data, then you are going to use the Xarray very important, like very often. And by the end of learning this particular library, you will be able to load, and you will be able to explore and analyze and visualize and export the multi-dimensional data set using Xarray uh, within the Google Colab environment, or whichever environment you are working on. So Xarray is again a Python library that makes it easy to work with labeled multi-dimensional arrays. So when we studied about NumPy array, then you would remember that we um, came across or read about arrays, and they can be one-dimensional, two-dimensional, or three-dimensional. And that library basically dealt with the values that are associated with a data set, or how we can handle the numeric data set particularly. But here in Xarray, we will be dealing with or working with the labeled multi-dimensional arrays. So multi-dimensional arrays, you can think it as a table uh, that has a multiple axes. Maybe let's say it has time, it has latitude and longitude and various other information. So if you since you have already used pandas, it was used for uh, handling your tables that comprised of rows and columns. So Xarray is like pandas, but for the data that has more than two axes. There we had just two axes of row and column, but here you will have when you studied in pandas, it just had rows, which are these, and columns, which is this, just two axes. But now, when you study X array, how is it different from the pandas? You will have more than two axes. Then you will also include maybe the time axis as well, along with the rows and columns. So here when we say that X array will handle the multi-dimensional arrays, it means that it can handle more than two data set at the same time. Like suppose if I have a certain region and I have multiple files based on the multi-temporal availability of that particular data set. Like for suppose, if I have the temperature data set for multiple time periods, like from 2000 to 2010. So I would have 10 different imagery of that particular temperature data set, and that too, if I say that it is a global data set, then you would know that it is for multiple locations. So I have the temperature data, which is available from 2000 to 2010. So it will have 10 different imageries, and those imageries are available for n number of countries and cities that are located in that particular region. Or if I have the global data set, then I will have that particular data set for each of the particular location, let it be India or different states in India. uh, and then I have all the Europe covered and every country or city within the European continent. I have information about temperature for 10 different years for all these locations. So when I say multidimensional array, I am talking about the entire set of data. But um when I say I have multiple datas or multiple multidimensional arrays, that means they should be of similar or same geographic location for all these uh, years. So if I have one imagery of 2000, that is for, let's say, for New Delhi. Then the other data set that is for 2001 should also cover the same area of New Delhi as the 2000 imagery. So likewise, I'll have 10 different data set or imagery of the same location of New Delhi for 10 different time periods. So I hope it is clear to you when I talk about X array, then I am talking about multi-dimensional arrays, which includes more than two axes, and I will have um, several different kinds of information that is stored in that particular um, data set. So like I said, that it saves you from keeping track of each of the axes, and it stores basically labels for each axis, so your code is clearer and less error prone because you have all the information within that particular code cell, or it is more organized and stored at one place. So array basically works well with formats commonly used in earth science or geoscience, such as NetCDF or grep and other libraries. Like, it also functions well when we work with or integrate it with the other libraries like NumPy, Pandas, or RioX array, which we will be talking about in our next lecture, where we will be combining the raster and the X array together in order to build a library which is RioX array, and it will have more functionalities together. And you will see how we can use its functionalities in order to fulfill our geoscientific work or um, um, objective that we have. So you can think of X array. So the data structure you can see here in this particular figure, that we have temperature, precipitation, and coordinate information in the form of latitude and longitude, and dimensions that say that you have X, Y, and time axis here. So the X array basically has two main data structure, and these are data array and data set. So what they particular mean is, when I talk about data array, it is a labeled multidimensional array which includes dimensions, coordinates, and attributes that you can see from here. So it will be a single variable that is present within that particular data set, uh, with labels in it. So a data array will hold one multi-dimensional variable. So in this particular data set that we have, temperature will be one data array that will hold the information about temperature for multiple time periods. Then I have another data array of precipitation that will hold the data set for multiple locations and multiple time periods. Then, so we can say that temperature and precipitation here, that comprise of one multidimensional variable, it is our data array. So you can also say that it is an n-dimensional NumPy array, but with the labels attached. So here you can know that this particular data array is for temperature, and this particular data array is for precipitation. So here these are my variables that I have for my particular data set. And what will be my data set here? So it will contain all these variables together with, you can think it as a file that will contain multiple fields. So it will contain your variable information, it will contain your coordinate information, it will contain your dimensions, which are in the form of X, Y, or Z axis. So this will be my data set. So the data set groups several of these data arrays together that share some or all the coordinate information. Like, for example, variables like temperature or humidity, or maybe some other variable of, like, say, wind speed, they all are defined on the same latitude, time, and longitude information, and they all will comprise of a single data set that comprises of all this information about the variables and their location and their time on a on the same grid that we have. So, like, for example, the netcd file, if you have come across any, then you would have seen that it contains multiple variables and data set that keeps them organized and aligned together. So this was about the X array, what is X array, and what is the structure of an X array. So the data array, which will be um, a single, or you can call it as a multidimensional variable that will contain the information about the variable or the location or the time axis, and all this data set when combined together forms the data set that contains all this information or store all this information together. So let's start with this particular uh, library and see its functionalities, how we can get started with this particular X-array Python library. So first, what we'll do is, all you know that we have to first install it. So I'll uncomment it and pip install X-array, and Pooch is some kind of weird, but I am installing it because I am going to use some of the tutorial dataset that are already available open access. So for using that particular dataset or those particular dataset, I am installing this particular library, which is Pooch. And yeah, so this is why I am installing Xarray and Pooch together. So once I execute it, so I can see that it is installed. Then I would import Xarray as XR. And simultaneously, I will also import NumPy because I am going to also integrate and see how we can work with NumPy, Xarray, and Matplotlib in order to plot any such information containing multi-dimensional data set in a particular or a single file that contains all this information together. So I am going to import all these three libraries, and once I have that, then I will use and let's see how we can load or open any of the data set. Like, for suppose here I want to open a tutorial data set. So this is a tutorial data set that we have, and for this particular session, I'm going to use these particular data set that I already have in order to show you how you can work with the X array. If you have your own data set available, you can use that as well, and I'll show it to you how you can open that particular data set on your computer. So, and X array is also very important and very useful because it does not store everything or everything in its memory. So it will use it temporarily and then it won't have it in your memory and maybe use some of the space or major space that is associated with that particular imagery or that particular data set, because you know that such data sets need a lot of space to store. So you have several of such data set, like you have the air temperature or air temperature gradient, and then you have mask boundaries, and then you have ice velocity. Then you can see that there are several information. So here I am going to use this air temperature data set, which is a NCEP reanalysis dataset and contains the information about the air temperature in that particular area. So you can explore this particular library where you library or particular website where we have some kind of example or tutorial data set available that you can use with the X array. So I am going to use the air temperature here. So for it, I will, since I have already installed and imported the X array, then I'll call upon the XR dot tutorial, because this is the tutorial dataset that I'm using, dot open dataset. If you have any dataset that is available in your computer, then what you will do is you will just type in xr dot open dataset, because it is already available. If some netcdf file or any such file is available, then you can use just open dataset in order to open that particular dataset for you. Because since I am using the tutorial dataset here, so I'll use the tutorial dot open dataset in order to open this particular dataset for me. So when you execute it, it will load the air temperature data. So here, what you see is you have the time information, you have the latitude and longitude. So can anybody tell me what is this particular data set telling me, or the dimensions about the data set telling me about? What is this dimension of time, latitude, and longitude telling me about? So in Rasterio also we read about it, that what all information. So I said that X array will deal with multi-dimensional arrays, and it will have more than two axes when I handle such data set using the X array. So earlier when we were studying about NumPy array, then we had only two axes. One was the row and other was column. So how many dimensions do we have here? So it is giving me the information about time as well, other than the latitude and longitude information. So here I have these bands of 2920. So I have 2920 bands that are available for these many times. Uh, this particular data set of air temperature is available for these many bands. So I have the data set that is for 2920 time periods. Also, I have the, what is this? Latitude is my row information. So I have 25 rows and I have how many columns? I have 53 columns that are available in this particular data set of air temperature. So I have the information of so many dimensions or so many variables and uh, coordinate information and the timely data set that is available within this particular file of air temperature. So when I check this time here, I will see that it is available from, it says 1st January 2013, and the time is hours, minutes, and seconds. So it starts from 0 hours and go till 6. So this data set is available for 6 hourly. This is 6 hourly data set. For every 6 hours in between the time period 1st January 2013 to 31st December 2014, I have this data set for every 6 hours. So how many total hours of data do I have? I have it for 2920. So it will tell you the time, uh, the data. So here time will be your data array, which is available for every 6 hours data set between 1st January 2013 to 31st December 2014. So there will be times when you are dealing with any climate data set or any other data set containing multiple information like this. So X-array will be very beneficial here or useful here in order to extract all the information that that particular data set might contain, or if you have like similar imagery of the same location for multiple time periods, like here you have uh, the data set for 2920, number of bands that are available for this particular data set. So you will have all this information within that particular file, and how you can process that particular data set that I am going to tell you in this particular library here. This is how you can open the data set and see what all information is available within that particular file. So Kaushik here has asked that, ma'am, any NC or NetCDF data we can analyze using XRL, right? Yes. So because your NetCDF file will contain the data set for multidimensional, it will be multidimensional data set that will have several different information within that particular file. So it will uh, unwrap that entire data set and tell you about various different functions that you can um, work with using the XRL library. So here that you see that the time period for what is available for this particular data set. And then I will also see, so my Another array is latitude that tells me about the number of rows for which the data set is available. So it will tell me, okay, the data set is available for all these latitude locations. And then I have the data set for all these longitudinal or the x-axis for all these coordinate locations, the data set for air temperature is available. So this is how you can access the particular temperature data set. Now, this data variable will be under the name of air. So this is my air temperature. So you can say that the name of the variable here is air. And it contains the information on a time, for what time the dataset is available, and for all these latitude and longitude information location that the particular dataset is available. And in total, you can see that how many total number of values do you have. So it's almost impossible for anyone to basically visualize using an Excel sheet. Like if you import this data set and uh, try to analyze and visualize your results of temperature uh, in Excel. So it's completely impossible for you to visualize your air temperature results because it has so many values that are stored, and it's impossible for anyone to visualize this result unless you manually maybe select any particular smaller area in order to visualize that result. But again, it will be very difficult for you, and then you will have to plot that particular information in the form of some spatial maps, because um, if you want to show it in your publication that what values and how the air temperature has varied spatially and temporally, then it's important that you analyze the entire data set in one go. So here, the importance of X-array comes in, where you can visualize all the entire imagery containing all these value information about the air temperature, and that is also available on a 6 hourly basis for 2 years. Then you can use X-array in this case in order to know all this information, and then analyze and visualize your results accordingly. So you can also see what are the attributes. So here you have conventions, and you have the title of this particular data set. Then you have the description in order to refer this particular data set where you have extracted this particular data set from. So it also gives you the reference for it. So all this information you can get using the X array. So this information we get when we open or load our data set using open dataset function within the X-array library. So next thing that we have is how you can work or access different information that you have stored within the data arrays. So data array will have the core data structure. It is one of the two uh, core data structure uh, in X array, and the other is data set. And as you can see here, one of the data structure of X array is data array, where we have individually all this information available to us. So now it includes various data values, like for temperature and precipitation. Then it has dimensional information about time or coordinate locations, about latitude and longitude, and all these information for each of these dimensions that you have in the data array. Now, if you want to access just one, maybe if you just want to access the temperature information about this entire data array that you have, then you will write, okay, the data that I want to have is temperature. So I have provided it a variable of temperature because I want the temperature data. And then you will just write ds, which is your data set that you opened initially. And then you will provide that particular attribute of air, which is this data variable. So since you want the temperature, just the temperature information of this data, one of the data array present in that particular entire data set, then you will provide the variable of air temperature, which is air, and you can know what all information is available in that particular data array, which is for temperature. So you will remember when we used to access any data set in NumPy, we also use a data frame. So there we had just the rows and columns. So we used to use the data frame in order to access any information. So we just typed in df, which was our data frame, and then within the square brackets, we provided that particular attribute or parameter that we want to, whose values or information do I wanted to extract. So here, in a similar way, I have provided the entire data set. So this is my entire data set. And out of that, I just want to extract the data array of temperature, this information. So what it will contain? It will contain the information about latitude of temperature, then longitude of temperature, and the time axis, or this is your time axis. And then here you have your latitude, and here you have your longitude information. So I'll have that for information about temperature when I access a particular data array of air temperature here. So it has provided you the data array of air temperature where you have time information, which is again same 2920 bands. Then it has latitude information or the rows of 25 and columns of 53 that is contained within this air temperature data array. Now, if you see this, it will again show you what all information it is. 6 hourly data from this time period to this particular time period. And then you have the latitudes that are available for this particular data set. Now, if mm, temperature. Now, suppose if, let me show it to you if I have any other data set. Mm, There are only temperature data set. Let's see if I want to work with any other data set. Here I have used the ice velocity dataset. So it will tell me how many rows and columns do I have. So here I have 800 rows and 500 columns. Then I have the data variable as this. So it will tell me how much inform for all these years from 1996 to 2007 I have this or 2012 I have this data available. Then the title is ice velocity, then version is this, then I have these many rows and columns that are available, then what is the projection of this. So it is available for any polar data set, which is maybe south. So it is probably Antarctic region that it is covering for computing the ice velocity. Then what is the latitude and longitude that it is covering? So it is minus 90 degrees, means it is south of the uh, equator. And then yeah, you can also read about the summary of this particular data set. So this particular data set is part of NASA making earth system data records for use in research environments program, and it provides a high resolution digital mosaics of ice motion of Western Antarctica. So I said that it will be somewhat near to the Antarctic region, with covering information about all these glaciers that are present in the Antarctic region. So you can get a lot of information. So it has also provided the reference if you want to refer this particular data set that you have. Maybe it is an open access data set that they shared when they published this particular the results of ice velocity in 2012. So they provided it uh, an open access to everyone, so that everyone else who is working with these glaciers or in that particular area can access or have the complete access to this particular information about ice velocity, and they can just attribute to that this particular publication while they are using their data set. So yeah, this is how you can use or see any other uh, open access, or if you want to have to analyze your own data set, then you can do that as well. I would suggest that you particularly, since you all are studying about the X-array, so I would suggest to download any of such NetCDF file or climate data set that you want to analyze and see in any part of the globe, and use all these functionalities in order to plot this information and visualize your results. So that we will see probably in the next or next to next session, when we study about the Rio X-array that will combine the functionalities of Stereo and X-array. So here I am telling you about how you can open that particular data set and access the different information in the form of data arrays that are present in that particular uh, data set. So in the data array, what components do I have? If I am accessing the air temperature data set, then I have the values, the actual data, which is the actual data that is stored in the NumPy array, because they will be certain values that will be stored in the NumPy array. Then I have the dimensions, which means the x, y, and z axis in the form of latitude, longitude, and time. Then I have the coordinate information, uh, which will be the values for each dimensions that, or the geographical location that I have, and I have the values associated with that geographical location and the dimensions. And then attributes, which means that what is the metadata that provides me the information about everything, about the x or y axis, then reference or citation, from where this particular data set is derived from, and all that kind of information about the metadata. It will be contained in the attributes. So you can extract and print that information that is contained in that particular data array. So when I want to access it, so I have the temperature information that I opened from here using the data set DS and in the bracket air. So it will again tell me all the values that it contains, this particular data array of temperature contains. So it will contain the values from 241.2 to 295.69. Now, if I want to check the dimensions, then it will tell me it contains the information about time, latitude, and longitude that you already saw in here. And also, if I see this particular diagram, you will see that I have this temperature which has multiple arrays or multiple imageries or multiple arrays that contain the information about multi temporal time periods and different geographical locations. So if this is my uh, y-axis, which represents the latitude, this will represent the time, and this will be my longitude information that will be contained. So this is the dimensions that this particular data set and data array has, and then it contains the coordinate information about what time is this data set available from. It is available from January 1st, 2013 to 31st December 2014. Then the latitude and longitude information that it contains. Now, if I want to check the attributes, that will be the metadata that is for this particular data array of temperature. So it will tell me what it is. It is daily air temperature data set. Then it will tell me what units does it have. So it is in Kelvin. And then what precision does it have? So it has a precision of 2. And then all the information that is related. Now, you can also, like, for suppose if you want to add any attribute to it, so you can use the similar kind of, when we were studying about uh, the dictionary, and if I wanted to add anything to it, what I did was, like, for suppose if I want to add the contributor key to it, which has the value of NOAA. So because this data set is available for NOAA, so let's uh, how you can add that particular information. So I'll use attribute, which will tell me about, sorry, it will be temperature, uh, temperature And then I want to inform dot ATRS. And within this, I want to include the information about contributor. So what I'll do is contributor equal to maybe no. So if I run this and then access the information about temperature dot ATRS. Now you will see it has added one more attribute, which is contributor, that we just added in your attribute list. So this is how you can also add any information in the attribute if you want to, using this method wherein you will provide your key, which is contributor, and here you provide the value that is associated with that particular key. By providing your temperature attribute, because we want to add this information within the attribute. So this is how, if you want to add anything to your existing data array attribution, you can do that. Now, this was about how you can access any information about I'm sorry, my just internet got interrupted in between. So let's cover everything else in Xarray in the next session, that is tomorrow, and we will complete the Xarray tomorrow. And this was just the introduction on how you can, what this library was about, and what components or what data structure does the Xarray has. And then we studied on how we can load any particular data set, where we saw and opened open access or tutorial dataset that is already available with the example of air temperature. And then we saw how we can access a particular data array that we have. Now we'll proceed from that. If we want to have a selected data set with a particular time and particular location out of that particular data array, then how we can do it. So we will start from there tomorrow. So thank you for attending this session, and let's proceed tomorrow.